Here's another common problem that I see people run into with generics. Let's say I have some collection of numbers. I'll make them double numbers. Numbers like 1, 2, 3, 4, 5, and 6. And what I want to do is compute some result from these numbers. Not just a simple average, but maybe a sample averaged. So something that's not built into .NET. I want a sampled average of the numbers so I can write out that result. Now let me use Visual Studio to create this method sampled average. It takes an array of double. It's going to return a double. And let's provide a very simple implementation. I'll count the number of items that I've sampled. I'll keep track of a sum. I'm going to iterate through the numbers, so up until we reach numbers.length. But to sample it, this is a very crude sampling. Just increment I by 2 instead of 1 each time. And then I could say sum plus equals number sub I. Also increment count. And at the end, return sum divided by count. Now there certainly could be some imperfections to that logic, but if I run the program, I'll get a 3, which does seem to be somewhere in the middle and looks good. And here's the problem as it relates to generic. Now someone comes along and says, hey, this algorithm that you work so long on, this sampled average, I need to use it with type int. So not just doubles, but also integers. And I might think to myself, this might be a place where I could use generic type parameters. So I could say sampled average of t. You give me an array of t, and I'll return a t. And the problem is t has to have certain characteristics. The plus equals operator has to be able to work with t, as does the division operator. And the C# compiler doesn't know if type t has those operators. So you might say, well, I'll use a generic constraint, except there is no way to specify a constraint that enforces certain operators on a type. There just isn't. You can specify base classes, you can specify interfaces, you can specify a default constructor, you can specify whether t is a reference type or a value type, but there's no way to say that it should have a plus equals and division operator. There just isn't a way to do it. And so quite often when you write mathematical code like this, that is using mathematical operators, you're going to just have to overload methods with different types of parameters and not use a generic type parameter. In other words, I'll need to create a sampled average that takes a double array, also an int array, perhaps a float array, a long array, a byte array, all different versions of sampled average because there just is no way to write code using generic type parameters and use operators. Now there are some cases where you can replace an operator with an interface definition. For instance, instead of checking if something like number sub I is less than some other number, well, the less than is an operator. I cannot enforce that. But I could enforce that t implements I comparable. That's an interface definition provided by the .NET framework. That would ensure that a generic type parameter implements that interface, and that interface has a compares to method. You can call it on an object, pass in another object, and it would return less than 0 if something is less than something else. So that would be a way of using an interface to avoid using an operator. But when it comes to things like addition, multiplication, subtraction, division, across the built-in types like int, double, float, long, the best solution there is not generic type parameters, but overloaded methods.